Right then, welcome back everyone. Let's solve this question, Bogosort. I'll quickly summarize the question for you. What they're given is we are given an array of n integers, even till en. So they will used one based indexing here, and they have defined a good array. So what is a good array? For each pair of indices I less than j. Okay, so for every possible pair I less than j, the condition j minus aj is not equal to I minus ai. Okay, so the difference between the index and the element is not equal for every I less than j. Fine. What they ask is, can you shuffle this array so that it becomes good? Now, when you do shuffling, you can maintain the initial order as well. So one shuffling is the initial configuration itself. Okay, you want to shuffle it such that for every two indices like this, I less than j, the condition like this is not followed. That is the difference between the index and value is not same. Okay, so they've given an example here. So these are the definition of good array, because if you observe here, this 1 minus 1 is 0, and you take this one index when any of the index greater than it, the difference is not equal to it. Similarly, this 2 minus 3 is minus 1, and you take 2 with any of the index greater than it, you will not find 2 minus 3 minus 1, right? And they have given a definition of not good arrays as well here. So for example, here you can see 1 minus 3 is 2, but if you pair this one guy with this 3 guy, so j is greater than I, but this difference 1 minus 3 is equal to 3 minus 5. So this is not a good array. Fine. So what they are asking is, give me the shuffled version of array which is good, and it is guaranteed that it's always possible to shuffle an array to meet this condition. That's what they have said. Concretely speaking, we are given an array and we want to print the shuffled version of it which is good. That is, this condition holds for every possible index. Okay, so let's just look at the question now. So here is the question summary, right? For every I less than j, I minus ai should not be equal to j minus aj. Then it is good. Fine. So how do you approach this question? First things first, let's just see like what makes like I minus ai equal to j minus aj, right? You can figure out when can this happen, then probably we can think about how to avoid it, right? So what I'm trying to say here is, let's just say I have two indices here, I and j, where I is less than j here, of course, and I have here ai and aj. So I'm just trying to look when this condition will fail, that is I minus ai equals to j minus aj. Okay, so let's just see the case where these are actually equal. Okay, so what do you get when you have I minus ai equals to j minus aj? Like, when can this happen? Firstly, what do you know here? So you know for the fact that let me just, like, if I put some numbers here, you will try to make more sense. So let's just say this I was 2 and this j was maybe 5. Okay, and let's put ai to be 7. Okay, ai to be 7. So 2 minus 7 is minus 5, right? So right now 2 minus 7 is minus 5. Okay, now when can these two guys be equal? When can like j minus aj be minus 5 itself? Notice one thing here. You are moving 3 steps from I to j, right? So you are going from 2 to 3, 3 to 4, and 4 to 5. So you moved 3 steps here, right? So in other words, you can say this 2 was increased to 5 when you move ahead, when you move from left to right. If you want this minus 5, the difference to be stayed same, this 7 will also have to move 3 steps ahead, right? In other words, if you put 10 here, this will still be minus 5, right? So I did nothing. Like, see, you know that I is less than j. So if you are reaching from I to j, of course the index will be increased to some part. And what is this difference? This difference is actually nothing. This difference, if I call it delta 1, it is actually j minus I, right? So you will move j minus I steps to reach from I to j. Now if you want the difference, like when will be the difference between I minus ai and j minus aj same? For simple reason, if ai also moves same number of steps taken from moving from I to j, right? So this difference I minus ai will be equal to j minus aj when you take the same number of steps required to go from I to j, right? So this aj, so this step here that you're going to take is delta 2, which is actually aj minus ai, should be if it is equal to j minus I, then it will be failing, right? And it's not a very difficult thing to see here itself. Like if you simplify this condition, it gives you the same thing. It gives you same thing, aj minus ai should not be equal to j minus I, right? So the number of steps taken from going from I to j should not be equal to difference between these two guys, aj minus ai, right? So either you can simplify this inequality and see it, or just by looking at some example you can see it that I minus a will be equal to j minus aj if same number of steps are being taken here. Okay, fine. So one thing but you definitely know, when you move from left to right, the index values always increase. Like there's like they always increase, right? When you go from I to j, that is move from left to right in an array, the index values always increase. Okay, fine. Now if you want this condition to fail, you just have to make sure this ai doesn't increase, right? Simple, right? See, these guys, the difference will remain same if this ai increments to aj same number of times this I was incremented to j, right? So we move forward 3 steps here. You just make sure ai doesn't move 3 steps forward. In other words, ai doesn't increase, because when you go from left to right, you're always gonna increase, right? The index value will always increase, right? When you go from left to right, if you can make sure this ai value doesn't increase, it can decrease or it can stay same. Simple, right? It just doesn't have to increase. Then I minus ai will never be equal to j minus aj. Simple, right? So you just have to make sure the values here either decrease or they stay same, right? If this you can ensure, then definitely I minus ai will not be equal to j minus aj. So I mean that's the question. So how can you make sure the values decrease or stay same? How can you make sure the values decrease or stay same? Simply sort the array in decreasing order or non-increasing order, right? So there's nothing to this question. The question is done and dusted. You just have to sort the array in decreasing order or non-increasing order, because when you go from I to j, the value will increase, okay? But when you go from ai to aj, either it will remain same or it would have decreased, right? So these two will be different. But this ai, when you go from aj, it will be either be same or it would have reduced. So definitely there will be inequality here, right? Pretty simple. Because when you go from I to j, that value is gonna change, okay? So if you can just ensure when you go from I to j, this value should not decrease or stay same, your job is done. And that's what it does when you sort the array in decreasing order. So the question is done and dusted, and here's the code for you. This is just taking the input and I'm just sorting the array in decreasing order. When you do it, you're guaranteed to get the array, which is good. And the time complexity is also very less here, right? So that's that, I guess, for this question. Then I hope you got something out of this video. I'll see you in the next one.